Okay, so welcome to today's class, and today we are going to discuss about a simple thing about very in a high level. We will discuss about Java threads and multi-threading. Okay, so what is the importance of threads and how we can implement multi-threading, and also how we can use threads related cases in our day-to-day programming, where exactly we can use. So, and what are the things we will be covered in terms of interview. Okay, we will cover this from this class. Okay, so are you clear?
Yes, okay.
Okay. So thread, actually, what is the threads actually? So thread is nothing but an event of action. Okay. For example, we are talking, right? So talking is also one kind of executing an event. The signal is coming from our brain, right? So I am talking to you, right? So that signal is coming from my brain. So from brain to in mouth, it is executed, right? So this is called one thread execution. So while talking, you're moving hand, right, with respect to your context, right? So you're moving hand. So that is also one type of execution which will comes from the brain signal. Okay, that is also one type of thread execution. Okay, and walking, when you are walking, you are going to step forward. So that is also one type of execution. That is also one thread execution which is coming from your brain. Okay, the thread is nothing but an event which is executed. A path of execution is called thread. Now threads. Okay. Threads are a program to operate more efficiently by doing multiple things at the same time, which is nothing but a multi-threading. Okay. So multi-threads are nothing but the operate more efficiently by doing multiple things. If it is a single thing, it will be a thread. If it is a multiple things at the same time, is nothing but a threads executions. Are you clear?
Yes.
Yes.
Okay. In Java, how can we create a thread in Java? In our Java core Java, how can we create a thread? By using thread class and a runnable interface. Okay. So there are two ways of create a thread by using thread class. If it is a thread class, we need to extend. Okay, we need to extend from the thread class. If it is an interface, we need to implement our my interface implementing from implements from runnable. My thread class extend from thread class. Like that we need to create to get the thread behavior. Okay, to get the threads behavior. So fine. So we can create two ways. Okay, thread class. So first of all, we will know about the thread class. So thread class provides the constructor. Constructor, you know, right? While creating a new thread, we can create like directly like this. And also it is allowing some of the parameters. Okay, parameters within this construction. So you can pass the string, the name of the thread. You can pass the runnable interface. Okay, why? Because whenever you are creating, right, in runnable interface we have a run method. Okay, so where you can override your logic related to threads. So you can pass the runnable interface, and also you can pass the runnable as well as thread name also. So these are the four type of constructors we have when you are creating a thread. Fine, that is fine. Now thread class provides the constructors and method to create a perform operations on the thread. Okay, thread class extend object class. Of course, object class is the superclass of all Java classes. Okay, object class and implements the runnable interface. Okay, this is also implements the runnable interface. Seriously, you need to remember thread class extended from object class. Okay, and implements the runnable interface. Okay, so this class is implementing runnable interface, and also it is extended from the object class. So thread class will have a run method from the runnable interface, and all object methods, what are the object class is having the methods which will have the thread class. So keep in mind. So now by extending a thread class, so it can be created by extending a thread class and overriding its run method. Why? Because it is also implementing a runnable interface. Runnable interface will have a run method. Okay, it is taking. you can see here, main extends thread. My class is extend thread class. This is public static void main. If you want to create your right, you need to create main thread. Your class is a new main thread dot start. Why? Because start method is coming from directly this class. Okay, which is extended already thread class. Thread class is having a start method. So I'm overriding this method, and also I'm overriding this run method. Why? Because run method is already have a thread class from the runnable interface. Okay, run method. Simply the output is this one. So let me check this one. Okay, thread demo one. Implements, right? Let me take thread. Okay, you can see this class. Okay, close all. Okay, so now you can see the class. Okay, so my thread extend thread class, you can see this thread class. So it is implementing runnable interface. Okay, which means whatever the thread is already having some priority, thread queue, top, right? Daemon thread, stillborn. Stillborn is the one type of variable. We need to check that. And also it is implementing a runnable interface. Okay, you can see here all these variables. Okay, yield method is there. In a thread class we have methods. Sleep method is there, and also sleep milliseconds is there. We can wait some time in a thread. We can init. So whenever the thread class is starting, we can initiate some whatever we require based on this method. And also let me check the start method. Start method. Yeah, this is the start method. So when you want to start a thread, this method you can call. Okay, so this is what in our thread class from the JDK library or Java library. Okay, so now you can create your thread class. Demo thread class is extended from thread. Okay, so whenever we are extending, right, in an inheritance concept, whatever the thread class is having, all the methods we will have here, right? So run method is not from the thread class. Run method is from the runnable interface. This thread class is already implemented a runnable interface, so it will come from grandfather to father and father to children, like that. Run is also coming. So let me execute this. Let me execute this Java application. Okay, this code is the outside of the thread. Okay, one is this code is the running a thread class. So this is the outside of the thread, and this is the thread class. Why? Because whenever you're starting a run start method, right, it will automatically call a run method. So this is what in a thread, and this is not a thread. It is a normal simple statement. Okay, normal simple statement. So it is out of thread. It is inside the thread class. Simple. Now here coming to here. So by implementing runnable interface, so you can create a thread by extending a thread class and also implementing a runnable interface. If you are implementing a runnable interface, you need to create a thread class and you need to start. Otherwise, without start, thread run method will not call. By calling a start method only, it will call. We can automatically call the run method. Okay, so if you want to call a start method, you need to create a thread. So if you are creating a thread, you need to pass a runnable object. What is the runnable object here? This one. Why? Because this main class is implementing a runnable interface. And now this. So let me go to this example. Go to this example. So just now we discussed it, right? So without thread, without start method, thread method will not start. Okay. So even we are creating a thread from a runnable interface or a thread class. Okay, or a thread class, right? So you are implementing a run method. You are overriding a run method from the runnable interface from your demo thread class. Okay. So this class is you are creating an object. That is fine. That is fine. But you need to create a thread class. Why? Why? Because from the runnable you don't have a thread class. Okay. It will be enable. You need to create a thread. we have a constructor, right? We can pass runnable interface also. You can see here constructor. That is the reason thread class is having a constructors. Thread class, you need to pass a runnable interface or a thread. Okay. Now in this object you are passing, what kind of object? Demo thread one. What object this one? It is in implementing a runnable interface. So it is a kind of runnable class. Okay, runnable. So now your thread class is ready. Now you can start your thread. So whenever you're starting, automatically this will come here. So this object will have a run method inside this one, and automatically this run method will call. So this is what creating a thread by implementing a runnable interface. Are you clear?
Yes.
Hello?
Yes.
Okay.
Yes.
Yeah, the same. Yeah, the same. After the starting thread, it is a normal statement. It is an out of thread class, which means out of thread. It is a normal, regular way of printing, taking this output. It is inside the thread class. Okay, fine. Now coming to by implementing runnable interface is also done. Now the difference between extending and implementing. So it is a normal generic thing. So extending and implementing. So extending, the major difference is that when a class extend a thread class, you cannot extend any other classes. Okay. So this is the basic simple difference from any classes, whether it is a thread class, whether it is a normal classes, right? It is a basic differences between the extending and implementing. So extending will always extend only one class. You cannot extend any other classes. Okay. So that is what here. Okay. So by creating a thread class, by creating a thread using thread class is a less priority, and by creating a thread class using implementing runnable interface is the major priority, the first priority. Why? Because but by implementing the runnable interface, it is possible to extend from another class as well. Okay. When you're extending another classes also, so you will get the properties from the other classes, so that you can reuse the code. Okay, reuse the code. So you can see here example, my class extend other class and implements runnable. So my class will get the few methods from other class also, and runnable interface also. Are you clear here? It is a very basic funda and basic simple difference. Okay.
Okay.
Okay. Now the life cycle of a thread. So whenever we are we are going to know about the life cycle, we are not going to much about each and every method, right? We already know. But whenever we are coming to the threads related interview questions, we are able to know the basic funda of the threads, and we can able to understand the things, and we can able to answer the questions. Okay. So this is the thread life cycle. Okay. So new thread, when you are creating a new thread, it will create an object. Okay. So you need to start. Without start, it will not run. Okay. Without start, thread will not start. So you need to start. Okay. So whenever you're starting, automatically runnable inside the run method will call. Runnable interface of the run method will call. So once a run method will call, already your program is running. From this, right, you can end up the execution. So the thread will be dead state. Okay. From this, or if you want to do some manipulations, you can use these methods: sleep, wait, join, yield. Some thread methods are there. Okay. So you can use. So sleep method will take long milliseconds to wait your program some time of milliseconds. Wait method will it is nothing but a wait method will pause your program until the get the notification from other class or other thread, right? So based on the condition, based on the scenario, you can go for the sleep method or wait method. So that is what the basic funda. So now you can, whatever we are discussing, right, the same I added here. The a new thread begins a life cycle in a new state. It remains the state until the program start the thread. It will be new state only until the program will be started. Okay. So whenever you are starting, automatically run method from the runnable interface will be called. Okay. So like that, I added all the information here. Now Okay, we can read, no issue. Runnable. After newly born thread is started, the thread becomes a runnable. The thread becomes a runnable means it ready to be run. It ready to be run. Okay, and a thread this state considered as a being execution task. Okay, it is running whenever the run method is calling, automatically it is running and it is executing that. It is executing the state means whatever you are implemented inside the run method. Okay, and waiting. Okay, waiting. Sometimes a thread transitions the waiting state while the thread waits for another thread to perform the task. So for example, in between after running before ending the thread class, it may do some activities by using other threads. At that time, you need to stop, or you need to pause, not stop, you need to pause the current execution some amount of time. Okay, by using sleep method. So that is what waiting period here it is the waiting period. Okay, a thread transition back to the unrunnable runnable to the runnable state only when another thread is single a waiting thread to continue the execution. Okay, another thread is continue the execution and the first thread is waiting state. And whenever the second thread is done the execution, it will notify, hey, my task is done, you can go to your task. Okay, it will, the task one, thread one, it will resume the next action of work. So like that we can go for the wait. Timed waiting. So this is the wait method, and timed waiting nothing but the sleep. And runnable thread can also timed waiting state a specified interval of time. A thread state transaction back to the runnable state when the time of interval expires. When the it will be waiting for, of course, waiting. Event is waiting. So whenever you are using a sleep method, right? You can pass 10 milliseconds or 1000 milliseconds or 100 milliseconds until that current thread will wait. Once it is expired or once it is time is up, right? Time is done, which means the waiting time will be expired. Then it will be automatically the thread from the runnable state to execution state will come and it will execute the rest of the statements. So this is what a main. Okay, and terminated and dead. So whenever your things are done, right, where your execution is done or your sleeping time or wait time is done, the rest of the statements will be executed. Finally, it will come to thread terminated, which means task executed completely. So this is what a thread life cycle. So are you clear here?
Yes,
Okay, fine. Now multi-threading in Java. Now multi-threading in Java. So we already discussed it, right? If it is a thread is a single thread, it is a single normal threads class. And if it is more than one thread is executing, it is a multi-threading. Okay. So in multi-threading, we have programmatical task-based thread-based multi-threading and process-based multi-threading. Okay. In a general concept, process-based multi-threading. So thread-based multi-threading is nothing but your program. Your programmatically you are handling multiple threads, but process-based in the sense, uh, which is coming nothing but a multitasking. Okay. For example, take your Windows system or your laptop. Okay. So you're listening a class uh, by by exi- by joining a Zoom method. So that is one task. And also backend you can run the program, that is also another task. And also backend you can listen the music, that is also another task, right? So and you can play the movie and you can keep silent, right? So and also the same way you can open the notepad and you can write the notes. So these are the different tasks. Okay, those are the process based multitasking in our operating system. The same way, a thread-based multi threading we can do through this program. How the things are different events are we are doing in a OS level. The same way, program level also thread-based also we can do the multiple things at a time. So that is nothing but a multi-threading. Multi-threading in Java, a process of executing multiple threads simultaneously. So that is nothing but a multi-threading. Java multi-threading is mostly used in games and animation and extra. So okay, games, right? So for example, games and shooting game, right? So multiple party one and party two, two parties are there, and the same part, A party and B party, two parties are there. In the A party will have n number of soldiers and B party will have n number of soldiers, which means n number of threads, right? So they are shooting each other. So these are the multiple members are doing a multiple events, right? So those are the one by one execution. So one by one execution. This is what multi-threading. So especially in a games and all, and the real-time programming also we can use a multi-threading. We will see what is that. Okay. Now, advantage of a multi-threading. It does not block the user because threads are independent and you can perform multiple operations at the same time. Exactly. So for example, you can listen your music, you can walk, and you can move your hands. See, moving hand is the individual event. Talking from the mouth is an individual event, and walking from your legs is an individual event, right? So these are the multiple things you can do at a time, right? So you can talk, you can listen, you can move your hand, you can step forward to your from your leg, right? These are the individual threads execution from the which are signals coming from the brain, right? The same way, our programming also, it does not block the user because threads are independent and you can perform the multiple operations at the same time. Okay. Independent means it will not depending on the anything. Okay, fine. You can perform many properties together in the it will be save time. Okay. So you can perform many tasks at a time. So that it will save the time. So threads are independent. So it does not affect other threads of execution occurs in a single thread. Okay. So whenever it is independent, right, it will not interrupt the other thread execution, which means you can do the multi-threading whenever it is needed, so that it will execute individually without depending on other thread or without interrupting the other thread. So when it will save the time, it will do the fast execution. Okay. So this is what multi-threading. So now we will see. So creating a thread by implementing runnable interface. Okay, you can see here one more multiple threads we are calling here. Okay, multiple threads. How we are calling, we will see in terms of multi-threading. So here is an example to create a new thread and starting and running it. Okay, so new thread, of course, it is a new thread, but we are calling two times. Okay, we will see how we are calling two times. Okay, here. So the step one, if your class is intended to be extend a thread, then you can achieve this by implementing runnable interface. You will need to follow the basic steps. Okay, if your class is intended to be extended a thread, then you can achieve this by implementing runnable interface. Okay. Okay, so your class can extend thread and it will be implemented runnable interface. So like that also we can create. Okay, so the steps two by this method. Step one, after first step, you need to implement a run method. You need to implement a run method by providing by the runnable interface. This method provides an entry point of the thread and you will run complete business logic. You can write and run, right? You can write your complete business logic inside the method. The following is a simple syntax. That is fine. Now, the second step, you will initiate the thread class by following the constructions. So you can pass the runnable interface and also name. Why? Because we are passing name. I want to know how many threads are creating and which thread is executing by taking the thread name. So that is the reason I'm passing this one. Where there is an object is an instant class in implements the runnable interface, and the thread name is the name given new thread. Okay, to a new thread. So whenever we are creating a new thread, the thread name we can get it. Step 3. Once thread object is created, you can start it by calling a start method. Of course, we already did some examples method which can execute and a call run method. So whenever you are calling a start method, right? So internally it will call a run method which is already defined in your class. Otherwise, it will call the default run method from the runnable interface. Okay, following is an example. So why it starts? Start is a method from the thread class. We can start the our thread class. So runnable demo. So let me open this demo. Okay, runnable demo. Yeah, runnable demo. So close others and also test also. I'm opening this. So you can see here. You can see here. So my runnable demo extends a runnable class, runnable interface. This is the class, and I have a thread class inside this, and also name. Why? Because whenever I'm creating this object, right? So I want to pass that thread and runnable interface, and whenever I'm creating a thread class, I want to pass this thread name. Okay, so runnable. It is a this constructor I'm creating here, runnable demo string name, thread name. Whenever you are creating, right, runnable demo, you will get a thread name. And the run method is also we are overriding this method. So system.out.println thread and thread name. What is the thread name? We are having current thread, and I value we are printing just I value, and the thread dot sleep. So just after printing each and every element, just I want to sleep the amount of time here. Okay, wait the amount of time here, for example. Okay, so whenever you are creating a sleep method, right? So it will extend, it will throw the checked exception. So that is the interrupted exception. Why? Because other thread can interrupt this thread, right? So that is the reason. If it is other threads are calling while executing this thread, so that is the reason forcefully it is handling the exception, internal interrupted exception. So we need to handle, otherwise it will give the exception. Fine. So thread name, it is exiting. Okay. After this class, automatically thread will be executed, and after executing, what is the thread? Okay, thread I want to know. So start method also I am having t is equal to null. For example, thread equal to null, this one, thread equal to null. You can create a new thread and you can pass the thread name, right? So you can have this this means runnable object comma thread name. Okay, t dot start. So whenever it is starting, automatically run method will call. So and this demo, in this class I am calling runnable demo test thread. Okay, one equal to thread one, and just I'm giving a class r1 dot start, and runnable demo 2 equal thread 2, r2 equals start. Okay, so let me run this class. Why? Because runnable demo is already we taken. Runnable demo is nothing but this one. Okay, this class. So inside this class we have all by starting method and all. So let me run this. Let me run this. Okay, so you can see creating a thread class. Creating a thread class, the first one. Whenever you are passing two threads, right? Two threads. So you are calling it r1 dot start and r2 dot start. Why? Because this is already having a start method. This is already having a start method. So in the start method, we are creating a simply a thread class. Thread class, and we are starting. Okay, we are starting. So here you can see the here you can see the output. Output will be thread, right? So you cannot expect the same kind of output next one. Why? Because threads are, it is not synchronized, it is executing individually, but maybe this thread will start here, and maybe next time this thread will start from here. Okay, so we will check by running this program multiple times. So exiting, that is fine, and creating thread is also fine. Creating a thread 2 and a string 2. Okay, let me run. See, so now this time thread 1 comma 4, thread 2 comma 4, thread 3 comma 4, thread 1 comma 3. So 1 comma 4, 2 comma 4, it is added. 1 comma 4, 2 comma 4, 1 comma 4, 2 comma 4. Okay, now you can see 1 comma 4, simply it is starting 2 only. After that 2 comma 4, right? So it may start anyway, right? So it will not stop, and it will create, and it will start. Okay, so are you clear this program? By using sleep, second thread will be executed. Okay, after whenever the second thread will be executed, after this time maybe this thread is also wait some time. So in that case, a second thread will be executed. So once it is executed, after sleeping time, it will be executed remaining stages. So in this sleeping time, it may occur the second thread sometimes in a first, and after the second thread will come, and after first thread wait for the 50 milliseconds. Meanwhile, it will execute the remaining threads. Once it is done, So thread is exiting. Exiting means, so it will come here. Are you clear?
Yes.
Yeah.
Okay. Okay. And also we are taking that name also by seeing that output. Okay, by taking the name. So this is one example. And now we will see. So even though it is using sleep method, or even though it is using the early method, I want to synchronization concept. Okay, synchronization concept. Why we need synchronization? Why? Because here, if you want to data in a consistent way, consistent means sequence way. So my first thread will be executed first, and second thread will be executed second time. So my third instruction will be executed will be third time. So that is what data consistency. So whenever we are not using data inconsistency, synchronize without synchronization, so output will come like that. Output will come like this. Output will come like this. Sometimes like this, and some previously we saw, right? So it will be, see, thread 1 is started first, and after that thread 2 started. Here you can see thread 2 started after the first one will be started, right? So like that it will be taken, right? So in that case, if you want to consist the data in a sequence way, you need to go for the synchronization. So that is what a synchronization in Java. Synchronization in the Java is the capability of controlling the access of multiple threads to any shared resource. So if you are calling in a same method multiple times via multiple threads, it will be synchronization will be is the responsible to execute all the in a sequential way. First will give the first order, first priority. Second will come second priority with the fraction of milliseconds. It will calculate, and it will give the priority for the accessing threads. So it will provide the sequence of syncing between threads, accessing threads. So synchronization. Java synchronization is a better option where they want to allow only one thread access shared resource at a time, which means in a fraction of milliseconds, 100 threads will be executed at a time only. But when you are considering synchronization, there is a slight, there is a very little amount of difference between the first thread and second thread and third thread. So that will be taken care by the synchronization in Java, right? Why we use synchronization? The synchronization is mainly used to prevent thread interference, which means whenever we are executing was first thread, second thread automatically interrupt that execution. It will take that output from the by waiting for the single thread. So to prevent such kind of interferences and to prevent consistency problem. So whenever we don't get that sequence of data, right, we can prevent this consistency. So we will get the data in a consistent way. Okay. 9. Thread synchronization. So manual execution, like synchronized method, sorry, synchronized block and static synchronization. So whenever you want to provide the synchronization, you can go for this is the corporation method, inter-thread communication. Internally, JVM also using the threads for executing multiple programs or multiple things in inside. But we are not going to this inter-thread communication, which is already inbuilt coming from the JDK or Java. So manual execution, this is the manual, not a mutual. Okay, manual exclusive. So like synchronized method, by using synchronized method and synchronized block and static synchronization, we will see, right? So these are the how we can helps to keep the threads in interacting another thread, right? So mathwell, right? So we will see synchronized method and synchronized block and synchronization using static synchronization. We will go for only one example. We can read the remaining two. Okay. Before going to the synchronization, how other thread will wait until the first thread will execute, right? So that is what the concept of lock. Okay, in the threads, what is lock? Concept of lock. So whenever two threads are executing, if you want to execute the thread one, now it will lock on the object and it will execute first, and it will release the once that execution is done. So that is what lock is nothing but. So synchronize is built around the internal entity known as a lock or monitor. every object has a lock associated with by it. Okay, every object is having a lock. By convention, a thread needs to consistent access of an object fields as to acquire objects lock before accessing them. Okay, so first of all, whenever a thread wants to access that method, right? So before it will access the lock. It will access the lock and applying the lock on objects or methods. And once it is executed, then it will release. Then it will access the lock for the second one. So in that way only the synchronization will be happens between the multiple threads, and the release the lock when it's done with them, which means when that execution is done. Okay, so now this concurrency, this is nothing but a concurrency contains the several lock implementations from Java 5 onwards. Okay, understanding the problem without synchronization. So let me run this problem. You can see here. So I want to print a table. Okay, I want to print a fifth table, 5, 10, 15, 20, like that. So for each and every step, I want to sleep 400 milliseconds. Okay, 400 milliseconds. This is the table. This is the class. Now my thread extending. So printable is the method. Okay, printable is the method. My thread extending thread class table t this dot t1 dot run t dot printable inside this method, this dot table, this class is calling inside the thread. Okay, this thread table class we are calling inside the thread, and I am passing as a parameter here this dot t. Every time object will be considered as the table object, and inside the run method I'm calling this method printable. Whatever we can write this logic right inside the run method. So the same again, my class thread to extend thread class, same my thread by taking the table again, I'm passing the run method. I'm passing here printable is a 100 milliseconds. So here it will take the thread sleep, right? Right, it will sleep 400. Now it will take the printable is a 5, and this is the 100 is the table. Okay, table value. So here the value into is the table value it will printed. So one is the fifth table and second one is the 100 table, but each and every table we are giving 400 milliseconds as a time slab or time difference. Now the test synchronization one, which means without we are not using any synchronization here. You can see here are using just we are using public wide here. So we are not having any synchronization here. Here also we are not having any synchronization. Here also we are not having any synchronization. Just we are checking that synchronization. You can see here fifth table 5 1 ja 5, 5 2 ja 20, 5 3 ja 15, 5 4 ja 20, 5 5 ja 25. And before that it is interrupting 100, 200, 300 and 400, right? So it is interrupting the behavior, right? So without synchronization, let it run. Okay, let it run. So let it run. So this is the table. This is the table. Sorry. So this is the table. You're trying to print fifth table here or nth table. So five we will print 5. Okay, n into I. So n into I means whatever you are passing a value here. If you are passing a 5, 5 into 1, 5 into 2, 5 into 3, 5 into 4, 5 into 5 up to fifth. It will iterate list. Okay, so for each and every iteration 400 milliseconds it will stop. It will give the time delay. Now thread one is the one class. Just I'm table call I'm using that table within the same package. Just I'm passing a fifth table here, n value fifth table printable fifth one I'm passing. Okay, so coming to second, here 100 table I'm passing, 100 table I'm passing. Okay, 100 table I'm passing. Now you can go for the test class, synchronization test class. So without using the synchronization, you can see here this example, understanding the problem without using synchronization. So how the output will come? No synchronization. Okay, so let me run this. So I'm calling 2 times. I'm calling it 2 times. Why? Because my thread new object, this is one object, and my thread 2, thread 2 also I'm creating it. Okay. Why? Because thread 2 is a responsible for the under table, and thread 1 is the responsible for 5 table. Okay. That is the reason I'm calling 2 objects here. So I want to print 2 objects, but initially I'm calling a 5th table, and the second I'm calling a 100 table. Now see the output, how it will come. See, 5th table is started, 100 table is started, then 5th table, 5th 2 will be started, and 103 will be started. See, this is what inconsistency. So previously I am printing here. You can see here, 5th table one time, after that 10, after that 200. We cannot guarantee the sequence of when the 5th table will start and when the 100 table will start. Obviously, the first statement will be started 5th table only. Why? Because we are calling object 1 here. Object 1 is nothing but T1. Thread 1 is nothing but 5th table only. But here, after that, we cannot give the guarantee which table will start. 2 times 100 table is started, and again 2 times 5th table is started. Again 1 time 100 table is started, and again 1 time 5th table is started, right? So we cannot give the guarantee. Run one more time. See, you can run multiple times. See, 2 times here it is started. Here it is a 2 times it is started, 5th table. So this is what data inconsistency. Whenever you want to consistency, if you want to say in a 1 by 1 thread execute, right, without giving the chance to other thread, you can go for the synchronization. So synchronization is nothing but by using a synchronized method or synchronized keyword, right? So you can pass. You can the same class you can see table. I used the synchronized. Okay. Whenever you are using synchronized, okay, whenever the first will come, right, it will lock until the execution is done. Until the execution is done, then only the second thread will be called. So you are calling 2 times, right? So first of all, lock will be applied on my thread class 1. So which is the 5th, right? You are passing a 5th, right? Fifth table. Okay. The first will be executed the 5th table only, 5 5s. Then it will execute the 100 table. Are you clear about the synchronization and as well as also lock concept?
Yes,
Yes, yes.
Okay. Let me run the second one. Synchronization, using synchronization. You can see the thread 1 and the table class. Table class is we are applying a synchronized, okay, synchronized a keyword within the method signature, right? Whenever you are passing, it will apply the lock on object 1, and it will take the control of table as well as a method. Okay, method. Okay, so it will call this method from the table class. Okay, so what is the table class? This is the 5th table. Okay, whatever you are passing here, that will be the first priority. Once it is execution is done, it will release the lock. Then it will allow to execute the second call. Second call, where we are calling the second call? Second call we are calling the thread 2. So thread 2, what we are passing here? Thread 2. So simply we are passing thread 2 is a 100 table, right? 100 table. Print table of 100. So this table will have a just dynamically we are passing here, right? This table will have only one method, but at a time it will take one value only, right? One time. But whenever you are accessing multiple classes, multiple tables, right? So you need to give the synchronization. That is what synchronization, by using a synchronization, by applying this synchronization method. So let me run this one. Let me run this. Run as Java application. You can see only 5th table only it will run. Then 100 table up to 505 Java till 105 Java. Why? Because our loop is repeating up to 5 only, right? So this is what a synchronization concept. Okay. Now the last one is the very important is the deadlock. So here this is fine. Now the new concept is called a deadlock. A deadlock is nothing but for example, see, this is the best scenario. Thread 1 is accessing thread 2. Okay. Thread 2 is accessing thread 1. Okay. Thread 1 is accessing thread 2, and thread 2 is accessing a thread 1. So thread 1 and thread 2 are calling each other themselves, each other. So it will never ending execution. Okay. This condition is called a deadlock situation. Okay, are you clear? So resource 1 is called resource 2 and resource 2 is calling resource 1. So it is a infinity loop will be happens. Okay, infinity loop will be happens. So this type of situations we should not write a code like this. Okay, whenever you're writing in a simple way, it will be execute. If you are writing in a complicated way, it will not execute. It will be deadlock situation will be happens. Okay, this is one of the important question. You can read this one. Okay, you can read this one. So deadlock in Java is a part of multi-threading. Deadlock can occur in a situation when a thread is waiting for an object lock. Okay, thread 2 is waiting for an object lock. At that time, you should not call thread 1. Okay, that is acquiring by another thread. A second thread is waiting for an object lock. Second thread is also waiting for the object lock that is acquired by first thread. Okay, so it is waiting for a first thread. Okay, since both threads are waiting for each other to release the lock, this condition is called deadlock. Okay, so we cannot call like that. We cannot write a program like that. You can see here. You can see here. This is also synchronized and this is also synchronized. Two are the individual synchronized. Okay, individual synchronized and resource 1 and resource 2. That is fine. Now you can see here. So in a resource 1 and resource 2, these are the two individual tasks. Okay, but here the thread 1 is locked resource 2 and thread 1 is locked resource 1. That is fine. And now the thread 2 we are creating. This is also resource. Here the resource 1 and resource 2. Here the resource 2 and resource 1. Okay, so resource 1 is we are calling a resource 2 here, locked resource 2. Okay, here we are calling a resource 2 and a resource 1. So vice versa we are calling. So whenever we are calling t1 dot start, t2 dot start, right? So it will be, of course we are giving time slave, time bound period, but inside this one, inside this thread 1 and inside this thread 2, they are calling each other. They are calling each other. Okay, thread 2 is resource 1 is calling resource 2 is calling resource 1 and resource 1 is calling resource 2. So whenever it is calling, right, it will apply the lock. So thread 2 will wait for the this one lock and the thread 1 will wait for these two locks, right? These two are called at a time. So this situation is lock. This situation nothing but a deadlock situation. So let me run the deadlock. Okay, deadlock. So let me run this. Okay, so thread 1 locked resource 1 and thread 2 locked resource 2. So this is not a good way of writing problem. We need to write see, it is a single program, right? Automatically it will run, no issue. If you are handling multiple things in the same way, it will the program will go for the never ending infinity loop. Okay, infinity loop. So at that time your performance will go very less, low. So at the time performance will go less and it is not recommended to write like this, right? So now you need to write resolve code, deadlock resolving code. So the way of writing, right? So you can see here the above, the solution for a above found its roots. Okay, in deadlock it is a pattern of accessing a resource A and B in the main issue. To resolve this issue, we will have a simply reorder the statements where the code is accessing shared resources. Okay, just reorder your statements. Okay, so whenever you are calling like this, you need to reorder this one. Okay, not calling like this. Okay, not calling like this. Simply now deadlock resolved class. Okay, deadlock resolved test class. This is one. Resource 1 A equals to test equals the new resource 1. Resource 2 equals the test equals the new resource. Fine. We are creating a two objects for each individual objects, and also these are the finals. Now you can see here try catch is there, and you are sleeping the time first of all. Whenever you are having the synchronized block, okay, and the synchronized 2. Okay, so this is the runnable object, and you are having a run method. Within the run method only, you're having a B thread and you're having a thread in block 1. Okay, so let me see here. So this is the runnable class. Okay, this is the synchronized. This is the synchronized one. See, this synchronized is having a nested synchronized is a B. You are not having out of this. Okay, so now it will be executed. It will be executed B comma A. Okay, B comma A at a time. Why? Because Within the synchronized, you have one more lock. Once it is executed, then only it will executed, right? It is not individual locks. Okay, it is executed first. It is B1 executed first, and then it will be executed nested synchronized. Now it will come here. Runnable. B is executed first. Okay, B is executed first. Okay, new thread start and new B to start. So you can write like this, and also here inside the synchronized. Okay, so it will not give any deadlock situations. So this is what you need to write like this. So inside the synchronization you can use whenever you are calling A and B, okay, and also B and A like this. Whenever your call is depending on two threads each other, you need to apply the synchronization concept like this. You should not use the individual. You should not use the individually. So this you can see here, resource 1 and resource 2, right? So even though it is also individual we are using, but we are not taking the finalization here. So that is what here we are getting. But this deadlock situation, we are getting a runnable class we are taking, and also we are calling two threads, and also setting resource 1 we are setting the values, and resource also setting the values here. Okay, let me run this. Okay, in block 1 and block 2. Okay, the statements. So this is the block 1 and this is the block 2. So here also A we are calling, here also A we are calling inside the B. Here also inside the B we are calling A only. So you are not calling a reverse in a reverse way. So in a same order you are calling. So this is what the avoiding a deadlock situation. Are you clear in which situation deadlock will happen, and in which situation we can write the code in a best order to avoid the deadlock situation? Are you clear?
Yes. Yeah.
Okay, so this is what a thread class is. Okay, so our thread class is done, and now we will see our where we are and what are the remaining parts. Okay, so here up to thread class is done. Okay, up to thread class is done, and we will have two main concepts. Okay, two very main concepts in collections and feature Java 8 features. Collections will take one class or two classes. Java 8 will take one class or two classes. Within three classes or four classes. Okay, 2 to 4 classes we will finish. Maybe I will take only 2 classes only for this, and whenever we are coming to the Java coding problems, right, I will cover these two. Okay, so next 2 classes will take collections and Java 8 features. Once these 2 classes will done, we will stepping into microservices. Okay, are you clear?
Yes, okay.
Yes.
Okay.
I have a good.
Okay.
I have a
And
question.
also,
Yeah,
tell me.
but it's about the collection. Could you explain to me how read safe collection will work, please?
Yeah, we will explain collections. Next class, we will explain collections and what are the collections, and what are the collection types are there, and what are the classes are there, and what are the interfaces are there, and how we can use the collections classes in an effective way, and where the collections use cases and classes and implementations. All we will take a class. No worry.
Oh yeah,
So
but with the treat safe, the treat how they manipulate collection with the treat.
yes, we will do.
Okay. Thank you.
Yeah, inside the class we will do. Okay.
Okay.
Collections, manipulations, and adding elements and removing elements, and deleting elements, and right. We will do all the things in collections.
Okay. Thank you.
Yeah, definitely. So we will do the things in programmatical way and use cases, and also interview level, interview areas also we will cover. Okay.
Okay. Got it.
Yeah. Thanks for your time, and we will meet tomorrow's class. Okay.
Thank you.
Thank you very much.